Hello, everyone. It's Harris McIntosh again, and welcome to another podcast of Professor Lewis's calculus class. Today, we're doing our limit problems, as you can see on the freaking window right there. Ooh, my bad. Um, anyways, so we're just gonna start off. We have about 10 problems to go through, and they're relatively simple. They're kind of like asking you what to find and everything. So I'm gonna run down through with you. So the first problem asks, are there are the three types of discontinuity present? Well, if you look at the function that I've uh, copied and pasted off of the worksheet onto the window, if you look there, you notice that while the function doesn't have three forms of continuity, which brings you to number two. Explain where the points of discontinuity arise. Now, the reason why I say it doesn't have all three forms of discontinuity is because the function has jump continuity, where you're jumping from one line to another at the same point at -2 and 2. So you see here -2, and then you see the -2 again, and that's going from your right and your left. And then you go down to +2, get your right and your left once again. And so you got jump continuity at -2 and 2. And then you also have a limit of infinity at point 2 itself. So if you look here at the 2 that has the closed circle, you'll see that it goes all the way down to -infinity on the y-axis and doesn't stop. And that's how you can tell when a function has a limit of infinity, where it just keeps going and going with no end. Number three, it asks to explain which type of discontinuity isn't present and state how to recognize the missing type from the graph. Well, if you've known what we've been doing in that class and everything, I think you could tell that removable continuity isn't present at all, because in order to tell where a function does have removable discontinuity, you would have to have a line and then a point standing alone by itself. And on this graph, all the points are connected to a line, regardless if they're a closed circle or an open hole. There's no standalone points at all. So removable continuity is not in this function. Alright, so moving on, we're going to find the domain of the function, which is number 4. And for the domain, basically you have to find all the x values of the function. So, starting from your lowest to your highest. So I kind of guesstimated, I guess, on where my function starts and ends. And I went ahead and said, and this is kind of closed off a little bit. I couldn't take the picture without trying to get. I didn't want to get the next question on it, but it starts from what I'm guessing at -5 on the negative axis, the negative x-axis, and then it goes to another close point over somewhere at 8 on the positive x-axis. And the reason, and you want to put these in brackets, see brackets down here, because that shows you that it's a definite point. Where you want to put anything in parentheses, that's basically saying around that certain number or the point of it. It's not an actual definite place. And I guess you can say, well, I'm not making much sense, but that's what you have to do, because I kind of guessed this. But I definitely believe that it's at -5 and 8. And so that's why I got the brackets over there. Alright, so that's what you would get for your domain. And now number 5, my bad. Ooh, I'm looking at the wrong thing. At number 5, you have the range of the function, which is looking from your lowest y value to your highest y value. Now, if you go back to number 2, where we said that we have jump continuity, a limit of infinity, you're going to use that as a part of your y, because it starts all the way from negative infinity. You see that there, how it doesn't have an ending, it just keeps going and going and going. Yeah, you're starting from negative infinity and you're gonna go all the way to positive infinity, which is somewhere around 4. So yeah, just put 4, and it's a closed dot, so you're gonna put a bracket since it's a closed circle. And because it's infinity, and infinity is just either a really large number or a really small number, you're going to want to put parentheses on it. So anytime you have infinity, positive or negative, put a parentheses on it. Just put a parentheses on it. Just make sure that you know that. And closed circles, always put a bracket. If it's an open hole and yeah, you feel like it's there and everything, just put a parentheses on that as well. Open holes, parentheses, close dots, brackets. Alright, so moving on. Now, for number 6, you're going to use the continuity checklist to determine if a function is continuous at x equals 1 and x equals 2. So I split this into 6a and 6b. Now, for x equals 1, the checklist, you want to start off, I started off finding the limit from the left side of 1, and when I did that, left side of negative of 1 right here, start off from here, and I'm gonna say negative 1 is like right there. And for that, starting out from the left side, I said that the number was 2. And so for the limit from the left side, that's going to be 2. And then you want to look back for the limit on the right side, going back. You're still going to meet up at the same place since it's all on the same line. And that's going to be 2 once again. And so then you find a final limit of x. The limit of x going towards 1. And it's going to be 2 as well. Because, you know, it's all on the same line. You're going to hit it. So that would mean, because all 3 of these are the same, the function is going to be continuous. Now, for number 2, it's going to be a little bit different, because if you've seen from the get-go, well, 6b, for x equals 2 is going to be different because you see from the get-go that it's split up. Like, you got 2 different lines that you're working with at that time. So, starting off the limit of as x approaches 2 from the left, that's going to equal 1. No. That's going to equal 3. My bad. From the left, 3. My bad. And as x approaches 2 from the right, however, that's going to be 1. Now, you notice because you have to start on whatever direction, since it doesn't give you like anywhere to go from the right side, you have to start down here, but it's still on the same line. Now, because the right and the left side aren't the same, the limit as x approaches 2 does not exist. You have to have everything the same in order to have a limit without looking from either sides. Otherwise, the limit is just not going to exist. Alright, so for number 7, it's asking us, does f of negative 1 exist? And now that's basically asking us, does the point negative 1 exist on any line? And so you go to your negative x-axis, try to guess where negative 1 is, and then if you go up, you see that it does hit the line. So if it hits the line, it exists. As long as it hits the line, that point exists, unless it's a closed circle. If you see any indicator that's saying it's like, if it's not on the line, if it's a closed circle, then it would still exist, but, you know, that's self-explanatory. Anyways, so then moving on to number 8, is the function defined when x is negative 2. Now, it's basically asking you, will the function have a closed circle, and it's a definite point when x equals negative 2. Now, you're looking at the graph once again. I keep on pulling this up to the graph. And you're going to look at negative 2. Now, at first, you might think, oh, well, there's an open circle there. And that just means around it, so it isn't defined. But then you notice that right above it, you have that 2 right there. That's a closed circle. So, as a matter of fact, the function is defined at x equals negative 2, just not at the one that you would instantly look at. Now, number 9 asks you to state how continuity and domain are related. And they're related because if an x value is included into the domain, the x value is continuous within the function. If it wasn't included into the domain, that means it was discontinuous. So you see where pieces kind of break off at certain points and everything, or open circles or whatnot. You wanna find all that, like all the closed circle points. That's where you're gonna be looking for your domain, and any gaps in between a function that's basically telling whether it's discontinuous or not. So that's basically how domain and continuity are related. Now for number 10, I might stump you a little bit with this one because I wasn't so sure of my answers, so I might have to take the L on this one, which sucks. But anyways, it asks you to determine whether the function is continuous, and the function they gave you was f of x equals 5 over 7x minus 2. Oh crap. So I basically looked at it in my notes, and I did what I could, and basically got the numbers under the square root out of the square root, because you can't have the square root under the at the denominator. And then what's greater than 0, and I want to get one of the numbers on a different side, so I added 2 to both sides. 2 cancels out from -2, and then 2 plus 0, that's +2. And once I did that, I divided both sides by 7. Of course, 7 over 7 is greater than 2 over 7, because 7 over 7 is 1, and 2 over 7 is a fraction. That's basically a part of 1, in a sense, part of a whole. And since it's less than that, any number that's greater than 2 over 7, that's going to be discontinuous. So you start from 2 over 7, and then you go on to negative infinity, and that's basically where I found where the function is continuous. So hopefully I helped you in understanding this, and if I confused you, well, I apologize in advance, and hopefully you can get the precious 13 or so minutes back of your life returned to you. Sorry I wasted your time. But all in all, I feel like we all worked on this together. We did a good job and did what we could. And I'll enjoy seeing you guys at class another day. Have a good night, good evening, good morning, whatever time that you're watching this. Goodbye.